Hello everyone, welcome to this section. In this section, we are going to talk about classes in C++. So classes in C++ help us to model real-world entities by bundling variables and functions into a single unit. So the classes are like a blueprint or template for creating an object. And an object is an instance of a class that represents a real-world entity, and they help us to organize and bundle data and functions logically and to reuse and maintain code efficiency. So it is important to use classes as we use functions as well. So in order to declare a class, I'm going to teach you in this video how to declare and access variables and functions in a class. So in order to declare a class, we use the keyword class and then the name of the class. In this case, I named them car. And then we need to choose the category in which we are going to declare the variables. So there are three different categories in classes. So let me write it down. We have protected, we have private, and we have public. In the next video, I'm going to discuss these three categories, private, protected, and public, and their differences. But just accept it from me that we are going to use in this video the public version to declare our variables because it is the easiest way to teach classes first. So let's first learn how to declare a class and how to use it. Then we are going to dive deeper into the concepts like protected variables and private variables. So we use the keyword class, then we type down the name. In this case, it is car, and we are having the brackets here. So this part is the class part. Then under the category of public, I am declaring two variables called brand and speed. They are of a string and integer data type respectively. And also, I'm having a function being declared in the class called display. So this function is of void type, so it's not going to return anything. Simply, it is going to print out the value for the first variable and the value for the second variable, and that's it. And in the int main function, we are creating an object of that class car. After that, we are having the object dot brand, which is this variable, as being assigned Toyota, and then the object which is car1 dot speed, the other variable, to assign number 118. And then we are still using this object dot display, which is the name of this function, to call the function. Basically, we are using an object to access whatever that is inside that class. In order to access whatever that is inside that class, we're going to create an object. And if you would like to access a variable or a function in that class, we are going to have the name of that object. In our case here, it's car1 dot, then you type down the name of the variable or the name of the function. Basically, in C++, in the beginner level, we just learn how to type down things in the int main function, and in the end of the beginner level, we learn about functions. So we ask functions to do certain part of the code for us. So the main function will become very clean and clear. So it helps to have an efficient code to have functions, and we call the functions in our main function to do some certain part of the coding or certain part of the mathematical operations for us. And if we want to go one step beyond that, we group the functions and relevant variables into one class, so the code becomes more organized and more efficient. We could have, for example, 2-3 different classes. In each class, we are going to have certain functions that are related and certain variables that are used in those functions. And we can have another class that contains, for example, another functions that are related to each other and holding the variables that are used in that functions. So this is why we're using classes basically. So let me run the code now. So when I run the code, I see that brand Toyota and speed 118 is printed. But how it is printed? We create an object. We assigned the Toyota string to the brand because it was a string, and then the 180 to the integer speed. And then when we call the function, this function is called, and this function is basically what it does is basically printing out the string and the integer that was in the public category of the class car. So this is how a function is called when it is declared in a class. However, another thing that we could do was, for example, here we are declaring and initializing the function. However, we could use this code, for example. Let me comment this part and also this part and provide a semicolon here. If I just declare the function in the class, I can use scope resolution to initialize the function outside of the class. So the first option is to declare the function in the class and put whatever that is that function is doing, put it in the class. If it's short, it's beneficial to write it like here, but if it's a function with like 200 lines of code, it's not efficient to put everything in the class, because the point of the class is to have an organized code. And if you're going to have like 10 functions and each of them containing 200 lines of code, it's not going to be efficient to put all the function initialization and whatever that function is going to do in the class. So in order to avoid that, we can simply declare the function here and then use a scope resolution, which is here, to initialize the function outside of the class. To do that, we type down the type of the function, we type down the name of the class, and then scope resolution or colon, and then the name of the function. And then we are going to write down what that function is going to do for us here outside of the class. So it's your choice, preferably if you're having large quantity of code in any of the functions, it would be better to do it this way. So you declare your function in your class, and then you're going to type down what that function is going to do for you outside of the class. Using scope resolution, you can do that. So basically, this is what the concept of a function of a class is. It is going to group relevant variables and functions into one single entity called class. So the code is more efficient and organized. And then in the int main function, to access the variables and the functions in that class, we are going to create an object of that class and then simply access the variables and the functions of that class. Thank you for watching. In the next videos, we're going to dive deeper into the concepts of the class, and also we're going to talk about public, private, and protected variables. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to review private variables in a class. So we would like to write a program that declares a private variable within the body of a class, and we are going to have two functions, one get function and one set function. The set function is going to help us to access the private variable outside of the class, and the get function is going to calculate the area of a circle. So here you see that I am defining a class called circle. I'm having one private variable called radius. It's a float data type. And in the public part, I'm having two functions. The first function is a set radius function. It's a void type, so it's not going to return anything and it accepts one argument r. So basically, when this function is called, the argument that is passed in the parentheses for this function is going to be set to the radius variable here. So we are going to use this set radius function to set a value for this private variable outside of the class. And then we are having another function called getArea, and it is going to do some calculation for us. This function is going to calculate the area of a circle with a radius that is already set here, and this is the formula for the calculation. Okay, so let's jump into the int main function. Here I am creating an object called C from the class circle, and I'm calling this function. In order to call this function, I'm writing down the name of the object, which is C dot the name of the function, and this function requires one argument, and the argument is 5. So I'm setting number 5 to be the value of this radius variable, which is a private variable. How? By calling this function. I'm calling this function with the argument 5, which is here, and this argument is set to be the value of the radius variable, which is the private variable here. Okay, and then in order to show the area of the circle with radius 5, I'm calling the getArea function, and getArea function basically is going to have the 3.14 multiplied by radius, which is the formula of the area of a circle, and do the calculation for me and return the output. So let me run this code. So the area will be 78.5. Basically, in this code, what I did was I created an object, I called the function. So when I call this function, let me type it down here, radius equals 5. Why? The reason is I'm calling this function with the argument 5 here. So this 5 is set for the radius variable, which is this variable, which is the private variable. So because it is a private variable, it is not directly accessible from the int main function. We need to access it through a function that is defined within the body of this class. Okay, so I'm setting number 5 for the radius, and then I'm calling this getArea function to do the calculation for me. So basically this function is going to return the output of 3.14 times 5 times 5. Why times 5? Because the radius was already assigned the value 5, and it is going to do the calculation for me and return the value, and the returned value is going to be shown here in the output. So when I run the code, you see area in the terminal and then the number that is calculated using the getArea function. So in this lecture, we reviewed how to declare a class and private and public variables, and then how to set a value for a private member of a class using a set function, and how to have an output using a get function for that private variable in a class outside of the class. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we are going to talk about public, protected, and private variables and how and when we should use them in a class. So we will start with private variables. They ensure data encapsulation by restricting direct access to sensitive data. For example, if we need to access a private variable outside of the class, we need to define a getter and setter function to maintain data integrity and access these variables. However, for protected variables, they are restricted to outside of the class code, but we can still access them if we have a class derived from current class. So using a protected variable, we can access the protected variable of a class if we are in another class that is derived from the current class. Okay, so it discusses the topic that is called inheritance that we are going to learn in advanced classes. And for example, if we would like to discuss private and protected variables, we can have, for example, when we use private variables, when variables should not directly be accessed or modified, even by derived classes. So ensuring strict encapsulation. For example, we can discuss the bank account balance for private variables. And for protected variables, we use them when variables should be hidden from outside code but accessible in derived classes for further customization. So let me start with an example in the code and implement this so we can understand it better. We have a class called example here. And for private variables to write them, we simply type down the private keyword with colon, and then whatever you write down in the following will be your private variable. So here I'm having a private variable called private var, and it's of integer type. And just for the reminder, we know private variable accessible only within the class. And for protected variables, in order to declare them, we have the keyword protected, and then whatever you write in the following will be your protected variables. And they are accessible within the class and derived classes. That these derived classes we are going to learn in advanced courses, not in this course that is upper intermediate level. And then we are having the public variables that are accessible from anywhere. So in the previous video, we learned about public variables that I'm going to give you another example in this video as well. But we know that they are accessible from anywhere. And our public variable is called public var. Our protected variable is called protected var. And our private variable is called private var. And in order to access private and protected variables, we discussed that we need to have getter and setter methods or function here. Okay? In order to do that, we are having a setter and a getter for private variables and a setter and getter for protected variables. What they are going to do is the following. So for a setter for private variable, we are having a function called setPrivateVar. It's a void type, so it's not going to return anything. And it has one argument that is integer. Basically, when we call this function with one argument, it is going to set that value of the argument that is passed to our private variable. So we use the setter function to initialize our private variable. And in order to show our private variable, we use a getter function. So we have a get private var, it's of integer type, and it's going to simply return the already initialized variable in our value for the private variable. Also, the same thing, the same logic happens for the protected variable. We are having a function of void type. It is accepting one integer argument here, and whenever we call this function with one value in the parentheses as the argument, it is going to set that value for our protected var, which is exactly this variable here. Okay, so we are setting a value for this protected var. This is why we call it a setter function. And for the getter function, for the protected var, basically we are simply returning the already assigned and set value for that private protected variable. So let me clear all of this with an example. So we defined a class here. We have one private variable, one protected, and one public. We have setter and getter for private variable. We have setter and getter for protected variable. Okay. So in the int main function that is here, we are creating an object of the example class. In order to access our public variable, we can do it directly using a using our object. So we type down obj, which is our object here, dot public var. Public var is the name of our public variable. When we are having obj.public var, we can basically set the value 10 for this variable. So they are accessible outside of the function. However, if I do the same thing for the private and protected variable, we are going to have an error. So let me uncomment this part. You see that it shows a message saying that private var is a private member of example. So we cannot directly do this here. And also we are having it is a protected member. So we cannot directly access private and protected variables outside of the class. In order to access them, we need to use our getter and setter function. First of all, let's talk about private variables. In order to access our private variable, we need to first set one value for it and then print out the output using a get function. To do that, we are having the object of the example class dot, and we are calling the function set private var. So this is this function, okay, that is going to set a value for our private variable. So we are calling the function set private var and passing the value 20. When I'm calling this function, the code comes up here and see this function here. So 20 is passed. So 20 is going to be assigned to the private variable, to the private var here. We could not directly access this private var outside of the class. However, now I created an object of this class, and using that object, I am calling a function of this class, and because this function is within this class, this function can access to this private variable. This is why when we are calling a function with an argument of, for example, 20, it is going to set that 20 for that private var. It is accessible within the class, and this function is indeed in the class. That is why this function can do that for us, and we cannot do it directly here. Okay, so I'm setting this value 20 for my private variable, and in order to show the output, I am having the cout and message to the user private var variable via getter, and then I'm simply calling the get function. I'm typing down the object that is created obj dot get private var function is called. So when I call this function is going to basically return the already set value for this private var. So it is going to show number 20 here. The same logic goes with the protected variable. So I'm having the object dot set protected var with the argument 30. So it is going to set this value 30 to the protected var, and then it is going to, using a get function, get protected var, it's going to return the output of the protected var for us. So if I run the code, we see that, okay, so here I'm having the private variable equals 10. So the public variable equals 10. So the public variable directly accessible outside of the class. Then I'm having my private variable via getter, which is 20 here. And then I am having my protected variable via getter, which is printed here using this line of code. So to summarize, we can access our public variable outside of the class basically anywhere directly. So no problem about public variables. However, with respect to the private variables and protected variables, they're not directly accessible from outside of the class. With respect to the private variables, they are only accessible within the class. So if we want to assign a number to private variables, we need to have a getter or setter function and setter function to assign a number to this variable and show out the output for us outside of the class. We need to call the function, and the function is inside the class. okay, and do the job for us. With respect to the protected variables, they are following the same logic basically. However, they can be accessible through either inside the class, inside the main class, the current class, or inside a class that is derived from the current class, okay, the mother class, okay. But this topic, which is inheritance, I'm going to teach you in the advanced level. This is not the topic for the upper intermediate level. So this is how we can access different variables in a class. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we would like to write a program that demonstrates encapsulation by creating a class account with a private member balance and public methods to deposit money and retrieve the current balance. To do that, we are having a class declaration called account as requested. It does have a private member called balance, and in the public part it is having a constructor that is going to set this value for the balance, initialize a value for the balance, and then we are having a void function that is called deposit, and it is going to insert and add whatever that is passed as an argument and value for this part to add it to the balance. So basically this part is being written like this: balance plus amount. So if for example the balance currently is 1000, if we call this function and pass as the argument like 500, it is going to calculate the new balance equals 1000 plus 500. So it is going to recalculate the balance, and we are having one get balance function that it is going to return the value for that balance that is a private member, and we need to have a constructor to set the initial value for this private member and a get function that is going to return this private member value in the end, because they are not accessible outside of the class and they are only accessible using functions or constructors that are defined inside the class. So to do that, we are having an object called ACC that is of account type. An object of this account class is created, and because we are having a constructor, when I'm having this number as the argument in parentheses when creating this object, basically automatically the initialization of construction is done, and this 1000 that is passed here is going to be set to the balance private member. And then I'm using the object which is ACC dot deposit, that is I'm going to call this number saying that okay, I'm going to deposit certain amount of money into my bank account, and I'm passing 500 number as the argument, which is the amount here. So the balance, the new balance equals the previously value that were defined and initialized for balance plus the amount. So previously it was defined to be 1000, which is here because balance was set to be 1000 using this constructor. And when we were initializing the object, we set the balance to be 1000 plus the amount that we are passing to this deposit function, which is 500 in our case, which is 500 here. So 500 is passed as the argument. So the new balance is going to be 1500. And then we are printing out the balance output. So balance output is accessible only through a function because it's a private member of this class. So I'm calling the object, which is ACC dot the function name get balance, and basically it is going to return the value of the balance in the output. So let me run the code. Okay, so the output is 1500. So let me review the code one more time. I am creating an object called ACC of this account class, and I'm having this 1000 number here. Why I'm having this number here? Because I'm having a constructor that is accepting one integer value. So if I don't have this number, I'm going to have an error, for example, as you see here, no matching constructor for initialization of a count, because we are having a constructor and this constructor is accepting one argument. We need to pass one argument to this constructor. It could be any number. I'm just by default saying 1000. And this 1000 is set to be the value for the balance. Okay, this line of code is exactly doing this line of code. Okay, it's the other way of writing this. Okay, and when having this, it means that I'm having balance equal to 1000, because the constructor account is going to accept one integer, and that integer is 1000. And that 1000, which is b here, which is called here, the argument is called b, that b is set for the to be the value of the balance. It is written either this way or this way. So meaning that balance is now 1000, which is a private member. So the constructor does the initialization for us. Okay. Then I'm calling, using the object, I'm calling the deposit function. This function is accepting one argument that is of integer type. So I'm passing one argument 500, and it is going to do a simple calculation for us. Balance plus equal amount. Balance plus equal amount exactly does this for us. Balance equal balance plus amount. So the new balance equals current balance plus the amount. And current balance is 1000 because we initialize it using a constructor, plus the amount. Amount, what is amount? Amount is the argument of this function. And this function is called with the 500 argument. The argument, the value for the argument is 500. Therefore, balance now is 1500. Okay, the new balance is this one. And then balance is calculated, but we cannot directly access this balance. Why? Because it's a private member. So to review, we can see that I cannot access this balance. You see, it says balance is a private member. This is why we cannot directly access it. If it was a public member, we could directly access it, but here, because it's a private member, we cannot. Therefore, to do that, we need to have a get function here. So a get function that is defined in the body of this class can access any member of this class, including the private variables. So this function is going to basically return the balance variable value for us. So I'm calling this function. So I'm counting balance in the terminal, then I'm calling the function using the object called acc dot get balance, which is the name of the function, and it is going to return the output of the balance for me. Basically, this is how we can work with a private member of a class. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about constructors and destructors. We're going to do a coding exercise with respect to them. So first, let me start with the introduction. What is a constructor? A constructor automatically initializes an object when it is created from a class, and it ensures object data members have valid values before use. And destructors are going to automatically release resources like memory when the project is destroyed. And it prevents a resource leak like memory leak and ensures proper cleanup. And when we're going to compare constructors and setter functions, constructors are used for automatic initialization at the time of object creation. However, setter functions are used to modify values later during the object's life cycle. So both can coexist depending on the use case. And the key properties of a constructor is that they are going to have the same name as the class name, and they're not going to return anything. They're not even a void type, and they are going to automatically called when an object is created and cannot called as explicitly like a normal function. So let me give you an example. Here I'm having a small example here. I'm having a class here, and I'm having a main function here. The class name is called rectangle. It has two private members that are length and width. And in the public part, we are going to have a constructor and a destructor. How do I know that it's a constructor? In order to realize that it's a constructor, you should check its name. So the name is the same name as the class name. So when we are having the same name as the class name, we realize immediately that it's a constructor. And when we are having a tilde sign before the name of the class, within the body of the class, we realize that it's a destructor. And here, basically, this constructor is getting two values. Here, it is taking two integers, and that are called L and W. And then these L and W are set to length and width respectively, that are private members of this class. And finally, we are having one getArea function that is going to return the area by multiplying length and width that are set using this constructor that are accessing these two private variables. So the key properties of a constructor, they are having the same name as the class. So you see the name of the class is rectangle, the name of the constructor is rectangle, and the name of the destructor is a rectangle. But when we are having the tilde sign before the name, we realize that it's a destructor. When we don't have that sign, it's a constructor. And it no return type, not even a void. So you see that it does not have, for example, int before the rectangle name. It does not have the void before the rectangle name. So no return type, not even a void. And it is going to automatically called when an object is created. We'll learn about this in the main function, and cannot be called explicitly like normal functions. So these two we are going to check in the int main function. So after having declaration of our class here, I'm going to jump into the int main function, where I would like to create an object of the rectangle class. So when I'm creating an object, the object name is rect. Now the object name is rect, and I'm having the 10 and 5 in the parentheses. So let me review how we were used to create an object. So here, for example, let me object, for example, here, when we were having not having the constructor and destructor, we could create an object with writing the name of the class and then the name of the object. However, because we are having a constructor and destructor, when I'm creating an object without providing the arguments here, we are having an error saying that no matching constructor for initialization of rectangle. So because it does not return any value, it does not have any number in the parentheses. So if I have 2 and 3 here, for example, now the problem is solved. Why it was a problem? Because previously we were not having a constructor and destructor. We were basically having the name of the class and then the name of the object, for example, here, and then semicolon. We used to create an object like that. But because we are having a constructor now that is here, and it has two arguments that are integers, when I'm creating an object, I need to consider these two integers within the parentheses. So I need to initialize numbers for this constructor. So basically, this is how I am creating my object called rect of the rectangle class with two values. The first one is the length, because the first argument is L and L is set to length. And the second one is 5, which is W, and W is set for the width here. So we see that automatically called when an object is created, one of the key properties of a constructor. So it is automatically called when we are creating an object. automatically the constructor is called and we need to pass the values we want for the initialization. And when we are creating this object and passing these two arguments to the constructor, this constructor is setting the initial values for these two private members. Okay, and when this has been done, the destructor is going to also be called automatically. When everything is done, it is going to call automatically, and I'm printing out this message for myself to the terminal saying that okay, object destroyed. Okay, so we know the flow of the program execution. And after that, we are having the cout message saying that area, and then we are having the name of our object, which is rect. Dot get area function is called. When get area function is called, it is going to multiply the length and the width that are set for these two private variables using our constructor. So let me run the code. So when I run the code here, we see that it calculates the area for us, which is 50 because 10 times 5 will be 50, and then shows the message saying that object destroyed. So object destroyed because the memory allocation is now released and we don't need to have any memory assigned to this class because the work with this class is finished and the program execution is finished. Then it is going to directly release the memory. So in this video, we learned about constructors and destructors. We learned that they are going to have the same name as the class name. They are not going to be of any return type, not even a void, and they are going to automatically called when an object creation is done, and we are passing the arguments for the constructors, and automatically the destructor is going to be activated when the program execution is finished with this class. And also we learned that we cannot explicitly call them like a function that we are calling here. For example, this is the line of code that we call this function, but we cannot explicitly call this constructor. But during the object creation, they are automatically called, basically. So it was a very good example of how we can work with constructor and destructor in C++ in a class. Thank you for watching. Hello everyone, welcome to this lecture. In today's video, we would like to write a program that demonstrates the use of a friend class by creating a display class that can access the private and protected members of the box class. Basically, a friend class is needed when another class requires direct access to private and protected members of a class. So it allows tight coupling between two classes for specific operations while maintaining encapsulation in other contexts. So let me give you an example. Here I'm having one int main function, one display class, and one box class. I'll start by the box class. So this box class is having one private member, that is length, and one protected member or protected variable, let's say, that is width. And in the public part, we are having the constructor here that is going to initialize the length and the width that are these two private and protected variables of the class. And also we are having a friend class declared here. So we are having class display and we're using the friend keyword here. So we're declaring this display class as a friend of this box class. Okay. Then I'm having this display class being declared, and in the public part, it is having one void function, and it is accepting in the argument, it is accepting an object of the box class, and it is basically going to access private and protected members of the box class using the object that is created. So b.length and b.width is going to help us to access the private and protected variables of the main box class. So as you see here, this function is of void type, so it's not going to return anything, and it is accepting an object of the box class as the argument. And using that object, we are accessing private and protected variables of this box class here. So let me jump into the int main function. So here we would like to write a program that initialize values for these two variables, length and width, and then access these two variables using this show function that is in a class, a friend class display. To do that, I'm creating an object B of the class box, which is the first class. And because it has a constructor accepting two arguments, I'm setting the length and the width. Length is the first argument, so 10 is going to be assigned to length, and 20 is going to be assigned to the width because W is the second argument. So the second argument, 20, and W is going to be assigned to width. So this is how we are initializing these two private and protected variables of class box. Then I'm creating an object for this display class that is called D, and I'm going to call this show function. In order to call this show function, because it is in the display class, I'm using the object of this display class that is D. So d.show is how I'm going to call this function, but this function is accepting one argument, and the argument is the object created from the box class. So, and the object created from the box class is B. So let me review it one more time. In order to call this function, I need an object from this display class, which is D. So I created an object called D from this display class. So I'm typing down D dot show, which is the name of the function, and as the argument, it is accepting an object from the box class. And the object from the box class is B. So this is how I'm going to call this function. And basically, when this function is called, it is going to use that object that is passed as the argument to access length and width of these variables, private and protected variables of the original box class. And it is possible to do it because the display class is a friend class to this class box. So if I remove this friend keyword, we will see errors here. Why? It says that length and width are private and protected members, and they're not accessible in this class. But when I'm adding this friend keyword, it allows me to access these variables. So let me run the code. So when I run the code, I see the output length 10 and width 20. So length 10 and width 20. Basically, in this video, we learned how to declare a friend class for our main class and how from that friend class access protected and private variables of the main class. And also we learned how to declare and initialize a function in the friend class and access and pass the argument of the first class object. In other words, we learned how to call this show function. In order to call this show function, I am having an object from the display class, which is the class that the show is declared in that one. So, and then the name of the function, then this function requires the object that was initially created from that main box class. So we learned these points in this video. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we're going to write a program that declares a friend function that is not a member of the class, but can access its private and protected members. So here I'm having a class called box. I'm having one private member called length, one protected member called width, and in the public part, I'm having the constructor here that are setting the length and width for us. And also we are having a friend function that is of void type. Its name is display dimension, and the argument, it is going to take one object of the box, which is the name of the class. And the void function basically is going to access the length and the width that are private and protected members of this class box. But this function that is here, display dimension, is a void type, but this function is a friend function of this box class. Normally, a function that is defined outside of the class cannot access anything inside the class. But a member function of the class can access anything that is in the class. But in this case, we are having a friend function. We could write a member function of this class to access private and protected members, but usually a member function a member function of a class is restricted to that specific class, and there are some functions that we can define them to be friends of this class and many other classes, so they can do the same job for us in different classes. They are flexible to be friend of different classes. So this is why we use friend functions when we are having different classes, and this function is a friend of different classes, a friend function of different classes, and they're going to basically do the same job for us. For example, this is an example only. So here I'm creating an object called b from the box, and I'm initializing two variables, 10 and 20, which are the length and the width. And here, instead of writing down length equal L and width equal W, we can initialize them like this. So length in the parentheses, we type down L, and width in the parentheses, we type down W. This is another way for initialization. They're going to do the same job basically. So we could either type it like this or type it like this. For example, L, and in the next line we could write width equal W, just like the previous video's example. And then when the object creation is done, the constructor automatically is going to be built and set these two values for length and width that are private and protected members of the class box. Then finally, we are going to call our friend function, and we are going to pass this object as the argument. So this object of type box is passed as the argument. This is why when we were initializing this function here, not only we were writing down a friend keyword to mention that this is a friend function, but we were having the argument to be of type box. So because it is going to pass an argument that is object of this box, which is in our case is b, because b is an object created of the type box, which is the name of our class. So basically this function is taking the argument as the argument is taking the object of box, and what it is going to do is the following. So the name is display dimensions. It's a void type, so it's not going to return anything, and it is accepting an object of box. So what it's going to do is basically see out and showing the message length, and then using that object that is passed as the argument can access the length and the width that are private and protected members. If we were not having this friend keyword here, it was not possible to access these two variables. You see, it says that length is a private member of box class and width is a protected member of box class, so we cannot access it. But when we are having this friend keyword, it shows that this function is a friend function of that class, so it is accessible for this function to access the private and protected members using an object created of that class. So if I run the code, we expect to see the length and the width of that are initialized using a constructor here in the terminal. So let me run the code. So exactly. So when I run the code, we see length and width is printed 10 and 20. But how? Let me review it one more time. So we are creating an object here of the box, which is called B, and we are using a constructor. A constructor automatically is initializing this 10 and 20, which is here. The constructor is here. So the first argument is L, which is initialized to be the length, the private member, and the second argument, which is 20 here is W, and W is the width that is setting the value for the protected variable here. And then I'm calling the display dimensions and passing that object as the argument. So this function is a friend function of this class, so it is possible to access the private and protected variables of that class as well. So this function is going to use that object, created object, that argument that is passed as that object that is passed as an argument. It is going to use that b dot length, b dot width, and this way it is going to access the private and protected members. So when I run the code and this function is called, we are having this message length 20, length colon 10 and width colon 20. Basically, the same values that are initialized using this object and constructor. So in this lecture, we learned about friend functions and how these friend functions can be useful to access private and protected variables of a class. Thank you for watching. Hello everyone, welcome back. In this lecture, we are going to write a code that demonstrates how to declare a class and how to create two objects of that class. So we are basically going to review the class creation and object creation from that class. So we are declaring one class here. The class name is person. We are having two public variables, that is one name and the other one is age. Then in the int main function, we are creating two objects, p1 and p2, from that class person, and we are assigning the name of the first object to be Alice and the age to be 25. We are also having the second object name to be Bob and the second object age to be 30. And in order to print out the output, we are having the cout p.name, then p1.name, p1.age, and p2.name and p2.age. So let me run the code first. So here we see that Alice is printed, which is the p1.name, which is the message here, and then p1.age, which is 25 that we assigned here, and then years old, the message that we show in the terminal. The same logic happens with the second object. So we have p2.name, which is Bob here. So Bob is printed, then is the message that we print in the terminal, and then we are having the p2.age, which is 30 that we assigned here, and years old is what we are typing down in the terminal. So basically, in order to have access to a public variable, this is a review, to a public variable, we can access it directly outside of the class. To do that, we created two objects. Each object is assigning a name and age. So age, so Alice 25, Bob 30, using this code. So the object name is either p1 or, for example, p2. And when we are having the name of the variable here, which is name here, or for example, we can have the p2.age. So this is how basically we can assign a value to our public variable using the object name dot the name of the variable in the class. And then if we would like to print out the same variable, we can type down the object dot the name of the variable. So the object dot the name of the variable, which is age in this case here. This is how we can type down, assign, and print out the value. And also, if we are going to call a function that is in that class, we can simply just type down the object like p1 dot, and then it follows the name of the function, for example. Thank you for watching. Hello everyone. Here we would like to write a program about bank account management. Here we would like to create a bank account class with methods to deposit, withdraw, and display the balance. Here is my class, and the name of the here is my class. The name of the class is bank account. In the private part, I have two variables, one string called owner and one double called balance. In the public part, I have a constructor called bank account. How do I know that it's a constructor? Because it has the same name as the class name. So it's a constructor and it takes name and initial balance. So two arguments is going to be taken, and then it is going to assign name to the owner variable, which is in the private part, and also initialize the initial balance to the balance variable. So whenever we create an object of this class, automatically the constructor is being built. However, with the creation of object, we need to pass two arguments as well. Then the first argument is the name assigned to the owner variable, and the second argument is going to be the initial balance, which is going to be assigned to the balance variable that are in the private part. So this constructor is going to help us to have these variables being assigned. Then we are having one function that is called deposit, and it's a void type, so it's not going to return anything. So it is going to just show a message to us. And when we call this function, we need to only have one argument that is of double type. And basically, it is going to take the balance and add that amount money that we are entering to the already existing balance. So this code equals amount exactly equals this code, balance plus amount. Okay, so the amount, for example, is being set, so the balance is being set with the constructor. So for example, let's say 100 is the initial balance, and then we are calling the deposit function with the argument of 500. So 500 plus 100, the balance will be 600, and basically this part is equal to this part. They are the same. It depends on what you want to choose. And then we are going to show this message saying that we deposited, for example, $500 in the bank account. Okay, we are going to go through it with numerical examples as well, but I'm just now trying to explain the code. Then we are having a void function here that named withdraw, and it is going to get as argument one double called amount. Okay, here when we want to have the withdraw, we check to see if the amount is lower than the balance, lower than or equal than the balance of the account. So if we have, for example, 600 in the bank account, we would like to withdraw, for example, 200. We check to see if 200 is lower than the balance of our account, which is 600, for example, and then reduce that amount from the balance. Okay, so this line is going to say amount equals 600 minus 200. So now amount equals 400. So this is basically what we are going to do, and show this message to the user withdraw and show that this amount was withdrawn. However, if the amount is not lower than or equal to balance, it means that the amount is larger than balance. So we cannot withdraw some amount of money from our bank account if the amount is larger than the balance. So we're going to show this message insufficient balance if this has happened. And finally, we are having another void function called display balance. And using this function, we are going to show the name of the owner that was initialized using the bank account constructor, using the constructor of this class, and then the balance in the output. So this is what our class is going to do. Here in the main part, I'm having an object called account created from the bank account class. And because we have a constructor and the constructor has two arguments, when we are creating the object, we need to have two arguments. The first one was the name and the second one was the initial balance of our bank account. So I would say, for example, John Doe is the name of the account holder, and I would like to mention that the initial balance in his bank account is $1,000, for example. Okay, so this is how I'm creating an object, and automatically this constructor is activated. When it is activated, it is going to assign John Doe to the owner variable, which is a string, and 1000 to the balance variable of the bank account. Okay, so now by creating the object, we are having an instance that Mr. John Doe is the owner of the account and has $1,000 in his bank account. So the balance equals 1000 now. Okay, balance equals 1000. Then I use this object account to call the functions from this class. So the deposit function is called and 200 is the argument. So when the deposit function is called, we are showing this message in the output saying that, okay, $200 was deposited in the bank account, but we are going to also have the balance plus the deposited amount. So now balance equals 1,200. Okay. After that, we are going to call the withdraw function with $150. So the withdraw function is called. First, we check the amount, which is 150, with the balance. So 150 is lower than 1200. Yes, it's true. This statement is true. 150 is lower than 1200. Therefore, this statement is true, and therefore this part of the code is going to be executed. So 150 is going to be reduced from that to 1200. So 1200 minus 150, we are going to have balance equal to $1,050. Okay. Then after that, I'm calling the display balance function, which is going to show the account holder and the balance in the account. So when I run this code, we see the message deposit 200. So the deposit 200 is being printed out in the output. Why it is being printed out in the output? Because we call the deposit function. So the deposit function with this argument is called, and then the deposited message in this part is being shown in the terminal. Then the withdraw function is called with the argument of 150, and 150 is lower than the current balance, which is 1200. Therefore, this statement is true. Therefore, we are going to reduce it from the balance, and this message is being shown in the output, withdrawal of $150. And finally, when we are calling the display balance function, here the owner and the balance is being shown in the output. So the owner is John Doe because when we were creating the object, we mentioned the name to be John Doe, and the balance is $1,050. So this is what we expected to see here after doing the deposit and withdraw. So this is how we can have a class for bank account management, and we can have different input, and based on the deposit amount and the withdrawal amount, we are going to have different output here in the program. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to create a student class that stores a student name, ID, and grade. and we would like to have a method to display the student's details. Here I'm having a class called student, and in the private part we are having three variables: string name, integer ID, and character grade. Then in the public part I'm having a constructor. How do I know that it's a constructor? Because the name of it is the same as the name of the class. So this is a constructor, and it has three arguments: one string, one integer, and one character. Basically, when we are going to create an object of this class, we need to have these three arguments. So therefore, the constructor is automatically activated. And the first argument is going to be assigned as a student name to the name variable in the private part. The student ID is going to be assigned to the ID. And student grade is going to be assigned to the grade. So it is going to initialize the variables. Then we are having a void function that has no return values, and it is going to just simply show a message for us in the output. So display function called display details, and we are having the message, the name, the ID, and the grade of the students. Here in the int main file, I'm having two objects being created. So the first object of the student class is called S1, and the second object is S2. When declaring the object, we need to have three arguments as well, because the constructor needs three arguments. And the first argument is the name Alice. The second argument is the ID, which is 101, 101. And the grade is A for the first student called Alice. Then for the second student, we're creating another object called S2. And the name of the person is Bob. The student ID is 102, and then the grade is B. In order to call the display details function for Alice, we're going to use the first object because we initialize the details of Alice using the first object. So s1.displayDetails. So it is going to call this function and then show us the details of Alice. And then I'm using the second object for Bob to show the display details of Bob. So I'm calling the display details function again. So this function is called twice, but with different objects, and different objects are assigned to different people and information. So when I run this code, I see this message in the output. So name Alice, ID 101. So ID 101, and the grade is A. Then name Bob, ID 102, and grade B. So this is how, in fact, we can have a student grade system using classes. I'm having a class, I'm having three private variables to access and initialize them. I'm having a constructor that automatically initialize them. So helping me very much in saving time. And then also I'm having a display function that is going to display some information in the output for me. So I'm creating two objects in summary. Each object, when it is created, it needs to have three arguments because we are having a constructor of three arguments. We are providing these information when creating the object, and then I use the object of each person. So for example, the first object is assigned to the information of Alice. I use Alice object, which is S1, to call the display details function, and then the object S2 for Bob information is used for Bob information. Therefore, I use S2.displayDetails. So this function is called again, and it is going to show information relevant to Bob. Thank you for watching. Hello everyone, welcome back. We would like to write a program to create a rectangle class with methods to calculate its area and perimeter. Here I'm having a class called rectangle. It has two private variables, length and width. Then in the public part, I'm having a constructor. And I know that it's a constructor because its name is the same name as the class name. So it accepts two arguments, L and W, two doubles. So L is assigned to length variable and W is assigned to the width variable. Then I'm having a function to calculate the area. It is going to actually return the length multiplied by width, and it is going to return a double value for me. And then I'm having a perimeter function, and it's of double type, so it's going to return a double for me. It is going to basically calculate the perimeter of the rectangle, so length plus width, and the result is multiplied by 2. Then that output is going to be returned. So here I'm creating an object from the rectangle class, and the object name is R, but because we are having a constructor, we need two arguments when creating our object. So I would say the length of this uh, rectangle that I'm talking about is 10.5, and the width is 4.5. So 10.5 is assigned to L, then 4.5 is assigned to W, then L is assigned to length, and W is assigned to width. Therefore, we initialized these two variables. Then I'm having this message in the output, so area and perimeter, and use the object R to call the area function and perimeter function here, okay? And when the area function is called, length multiplied by width, the return of this, the output of this multiplication is going to be returned here and shown here. Then when I call the perimeter, it is going to calculate this for me and return the output. So when I run this code, we see that the area equals 47.25 and perimeter equals 30. So we see that we are having an object of this class and assigning these two variables to these two numbers to these two variables using a constructor. Then each function is going certain job for us. So area function is just multiplying length by width, and then the perimeter is going to calculate the perimeter of this rectangle for us and return the output here when I run the code. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have a library book management. So we would like to create a book class that stores the title, an author, and the availability of a book. And we would like to have a method to borrow and return the book. Here we are having a class called book. It has three variables, one called title, then author, and then a boolean to see if it's available or not. So is available. Then we are having a constructor called book. Because the name is the same as the name of the class, we know that it's a constructor, and it has only two arguments, the book title and the book author. So book title is going to be assigned to the title string. Book author is going to be assigned to the author string here. Then by default, we are going to mention that the book is available. So true is assigned to the Boolean data type that is called is available. Then we are having a function called borrow book. So it's a void type. It's not going to return anything for us. We check to see if the book is available. So when we call this function, we first check to see if the book is available. If it is available, first make it unavailable and show this message that, okay, you borrowed this book. Okay. Otherwise, say that, sorry, the book is not available, so it is already borrowed. We are having another function called return book. It's a void type, so it's not going to return any value for us. Here we are checking to see if the book is not available. So when we are going to return a book, the book is not available at the library. So if the book is not available, assign true to the is available variable, meaning that, okay, make it available. Then show this message saying that you returned this book, for example. Otherwise, you can say the book was not borrowed. Okay. If the book is available, we say that the book was not borrowed. So maybe you're making a mistake, for example. And if the book was not available, it means that we already booked the book, we already borrowed the book, and now make it available because we are returning it. And then show this message that you returned, for example, this book. Then we are having a function called display details. So this function is going to print the title of the book, the author, and the availability of the book. So it is going to check if the book is available. So if this statement is true, it is going to return the book is available, this message. Otherwise, it is going to return not available message in the output. So this is a ternary condition here that we see. Ternary is used to shorten the instead of if conditions, because if conditions are longer than them, but in single line we're using a ternary operator to have our condition being executed. So if this statement is true, is available equals 0, show this message available. Otherwise, show not available. And the condition is separated by a question mark from the two potential output, and two potential outputs are separated by a colon. Then in the int main function, we are creating an object from the book class. So the class name is book. We are creating an object called book. We can have B, for example. For the sake of simplicity, I put B. So we are creating an object called B from the book class. When we are creating, because we have a constructor, and constructor is taking two arguments, so the name and the author. So I would say the name Harry Potter, then the author is J.K. Rowling. Then using this object, I'm going to call the function. First, I'm going to call the function to display the details. So I would like to see if this book is available or not. So it is going to show the title, author, and availability. Then I'm calling the borrow book function. So I'm checking to see, okay, if it's available, make it unavailable and borrow it to me. Then again, display the details to show you the details that now it has become unavailable. Then the return function is called return book and make the book available because it was unavailable because I had borrowed it before, and show this, okay, you return this, and again display the details. So let me see if you're doing everything correctly, and now it's available that I returned the book. So when I run this code, first of all, I'm displaying the details. So the details is this. So the title, Harry Potter, author, J.K. Rowling, and availability, it's available. Okay, because is available equals true. This statement is true. Then call the borrow function. When the borrow function is called, we are making it unavailable, so false is assigned to is available, and showing this message, you borrowed the book. So you borrowed Harry Potter. Okay, so therefore now it has become unavailable. So when I call the display detail one more time, we expect to see that it's not available. So this message is shown. It says title, Harry Potter, author, J.K. Rowling, and then availability, not available. Why? Because is available equals false. Because it equals false, it is going to show not available for us. Why it is equal to false? Because when we called the borrowed function, it was available in the beginning because it was equal to true. But because we borrowed it, we assigned false to it, so it became unavailable. Then this message was shown to us. Okay, so this is why it is not available anymore now. Then I'm calling the return book function. It says you return Harry Potter. So returned, it says that, okay, the book is not available yet. Yeah, this statement is true. Make it available because I returned it. And this message is shown in the output. You returned Harry Potter, for example. You returned Harry Potter. After that, when I call the display details function one more time, I see that now the book has become indeed available. Why? Because we returned it. And in the return function, it was this boolean is available was equal to false, but we assigned true to it because we were planning to returning the book. So this is how a class can help to have a library book management. And it's very convenient. As you see, it's very user friendly. We just need to know the syntaxes to easily manipulate the data. Thank you for watching. Hello everyone, welcome to this course. In today's video, we would like to create a calculator class with methods for addition, subtraction, multiplication, and division, and allow the user to perform basic mathematical operations. Here is my class. I use the keyword class to create the class, and the name of the class is calculator. In the public part, we see that we are having four functions. The first one name is add. It is of double type, so it is going to return a double. And then it is accepting two doubles as arguments, and basically it is going to return a plus b for us. So the first argument plus the second argument. The second function name is subtract, and it's the same thing almost. In the initialization, we see that it is going to return a double. It accepts two doubles. However, it is going to return a minus b in the output. So you see, here is the definition of the function. Okay, because it's very short, I'm typing it down in one line. And then I have the function called multiply. It is going to return a double, and it is accepting two arguments that are of double type. And basically, it is going to return a multiplied by b. So the first argument multiplied by the second argument. After that, I'm having a function called divide. It is going to return a double value. It accepts, again, two doubles, a and b. But before returning the results, we are going to check if the second number is not equal to 0, because mathematically speaking, it's not possible to divide a number by 0. Therefore, we are going to check that first. So if b is not equal to 0, return a divided by b. Otherwise, if b, it means that if b equals 0, return an error, show this message to the user, error division by 0. So they know that they entered the wrong number. Here in the main function, in order to use these functions of this class, I'm having an object being created from the calculator class. So this object is called C. I have two variables that are of double type, and they are called num1 and num2, and I'm having a character called op. So I'm going to show this message to the user, enter an operation, either addition, subtraction, multiplication, or division. So we are going to ask this from the user, and we are going to store the user input in the op variable. Then I'm going to ask the user to enter two numbers, okay? After that, the numbers that the user is going to enter is going to be stored in num1 and num2. After that, we are having a switch statement. And in parentheses, we are having the OP. So depending on what operation the user is going to enter, is going to choose, let's say, we are going to have different cases. So in case the user is going to enter, for example, addition, we're going to implement this line, okay, this line. For subtraction, this line. For multiplication, this line. For division, this line. And if the user is going to enter, for example, an operation apart from these four, we are going to fall in the default case which says invalid operation. So if the user is going to enter addition, we are going to use the object of the calculator class to access the add function, which is this function here, okay? And pass these two numbers that we read from the user as the argument, and this function is going to basically add these two numbers and return the value in the output. So the output will be showing the a plus b. Then if the user is going to enter, for example, subtraction, then this case is going to be implemented, and in this case we are going to use the C object from the calculator class again to call the subtract function. This function is going to return us a minus b, and these two numbers are passed to this subtract function as arguments. Then the return would be a plus b, a minus b, sorry. The same logic goes for multiply and divide, and if the user is going to enter any operation apart from these four that we showed here, it is going to fall in the default part, and it is going to show this message in the output saying that invalid operation. So when I run this code, it asks me to enter an operation. So here is the program being executed. I mentioned addition, so enter two numbers, I would say 2 and 4. It says the result is 6. So I entered addition. Here, OP equals addition, and the case addition is activated now because they're equal. And then the function add is called, and num1 and num2 that are 2 and 4 are passed to the add function, and as the result we are having a plus b, which is 2 plus 4, and the result is 6. So if I run one more time, I choose, for example, minus, I would say 5 and 1, the output is 4 because the subtract function is called. If I have, for example, the multiplication operation, I would say 2 and 3, the output is 6. And if I have division, for example, and I have the first number is 5, the second number is 0, it says error division by 0, because we mentioned that here we are going to check if the second number does not equal to 0. If it's not equal to 0, return a divided by b, otherwise return this error, that this error is shown in the output as you see it here. So if I have, for example, now 10, oh, sorry, I had to choose the operation first. So if I choose the division and then this first number is 10, the second number is 2, the output is 5. Basically, it is going to divide 10 by 2 and the output equals 5. So this is how we can have a class, and within that class we are having 4 functions, and each function is going to do certain operation for us, and in this case they are addition, subtraction, multiplication, and division. And based on the user input we are going to call the function and do the operation on the arguments that are the numbers that the user is going to enter as input. Thank you for watching.